All right, this lesson is called Proving Lines Parallel. So if you see a notes in your notes, guys, we're going to talk about the same types of angle relationships we talked about 2 lessons ago. Yeah, corresponding angles, alternate interior angles, alternate exterior angles, and the consecutive interiors. All right. It says you can prove lines parallel by the following reasons, and these are your 4 reasons right here. 2 lines are cut by a transversal, so that corresponding angles are congruent, then the lines are parallel. So the example right here, guys, I'm going to use, let's say, if angle 1 is congruent to angle 5, then line L is parallel to line M. For the alternate interior, let's pick out some alternate interiors. Let's go with 4 and 6. If angle 4 is congruent to angle 6, then line L is parallel to line M. Alternate exteriors, let's pick on angles 1 and 7. If angle 1 is congruent to angle 7, then line L is parallel to line M. And the last one, consecutive interiors, we can go, let's go 4 and 5. If angle 4 plus angle 5 equals 180, then line L is parallel to line M. All right, so if you have one of these 4 cases, we can prove that 2 lines are parallel to each other. Practice. This is given the following information, determine which lines, if any, are parallel. State the converse that justifies your answer. Remember, the converse are one of the 4 up top we just talked about. All right, so angles 2 and 4. So 2 and 4 are on line A, it's a transversal. That would mean that line C is parallel to line D. And what types of angles are 2 and 4? Those are corresponding. So your converse for that case that proves them parallel, corresponding angles. 5 and 10. 5 and 10 are on line C, which would mean that A is parallel to B. What type are 5 and 10? 5 and 10 are alternate interior. That proves those lines parallel. 6 and 10. 6 and 10 are on line C as a transversal, which would mean A is parallel to B. Consecutive interior angles. 1 and 14, there's 1, there's 14. They're on line C, which would mean A is parallel to B. And 1 and 14 are alternate exteriors. 14 and 15. 14 and 15 are on line B, which would make line C parallel to D. And those are consecutive interiors. 11 and 16. Okay. 11 and 16, those are vertical angles, but that does not tell me which lines are parallel whatsoever. So vertical angles, I cannot prove any lines parallel. So this guy gets a none. 4 and 15. There's 4, there's 15. They're on line D, which makes A parallel to B. And those are alternate exteriors. 10 and 12. There's 10, there's 12. They're on line B, which makes C parallel to D. And 10 and 12 are corresponding angles. 9 and 13. There's 9, there's 13. Yes, I have 180, but that is a linear pair. With linear pairs or vertical angles, we cannot prove any lines parallel. So for linear pairs, we cannot prove any lines parallel. 2 and 7. There's 2, there's 7. They're on line A, which makes C parallel to D. And 2 and 7 are alternate interiors. Last one, 6 and 11. There's 6, there's 11. There is no line connecting 6 and 11. So we cannot prove any lines parallel with that one. That's a none. Next page. All right, same stuff we did for number 1, just another example. 9 and 22. There's 9, there's 22. They're on line S, which makes Q parallel to R. And 9 and 22 are alternate exterior. So in this case, I don't need this top line right there. So if I just use my sticky notes again and cover up that top piece, I can kind of see why 9 and 22 are alternate exteriors, because the line that I'm not using, I'm just going to cover up. So 9 and 22, those are alternate exterior angles. 8 and 13, there's 8, there's 13. I'm not using this bottom guy right here. The parallel lines would be P and Q. So P is parallel to Q, and those are consecutive interior angles. One and 17. There's 1, there's 17. I don't need to use this middle line. Can't really cover it up. But if I check it out, there's 1, there's 17. If I got pretend line Q is not there, those would be corresponding. So the parallel lines would be P and R. Corresponding angles. 16 and 20. There's 16, there's 20. I don't need the top part. 16 and 20 are on the inside, opposite sides. Those are alternate interiors. And then Q is parallel to R. Alternate interiors. 5 and 24. There's 5. There's 24. So I don't need the middle line. So it's kind of cover up that middle line with something. These are alternate exteriors, and line P would be parallel to line R. Four and 17. There's 4. There's 17. I don't need the middle line, so pretend that's not there. They're both on the inside, same side, consecutive interiors. And that would mean line P is parallel to line R. Ten and 13. There's 10. There's 13. We got an issue here. 10 and 13 do not have a relationship whatsoever. There is no relationship, which we cannot prove any lines parallel with those two angles. That's a none. H, 3 and 22. There's 3. There's 22. You do not need this middle line. Pretend it's not even there. 3, same side. One's inside, one's outside. These guys are corresponding angles. 3 is on P, 22 is on R, so P is parallel to R, corresponding angles. 5 and 15. There's 5, there's 15. I don't need the bottom line. Both are on the outside, opposite sides. Those are alternate exteriors, and P is parallel to Q. Uh, 11 and 16. There's 11, there is 16. There is no relationship with these two angles. Once again, just like letter, what was it, G? No relationship. You cannot prove any lines parallel. That is a none. All right, 2 quick little proofs. You will not see these proofs on a quiz or a test or a final, but let's knock these out real quick. There's shorties. If you want to go through them, we can go through them. If not, you can fast forward. All right, given 4 and 5 are supplementary, and we got to prove that J is parallel to K. All right, first reason always given. 4 and 5 are supplementary. Yep, gotcha. Now go back to last chapter, guys, where we talked about angle proofs. If 4 and 5 are supplementary and they add up to 180, that was your definition of supplementary. Remember, just to kind of recap, if they're supplementary and made a linear pair, that's your supplementary theorem. But if they add up to 180 and are supplementary, that's your definition of supplementary. Okay, now we got to figure out, okay, what types of angles are 4 and 5 to prove that J is parallel to K? Okay, 4 and 5 are inside, same side. Those are consecutive interior angles. So J is parallel to K because 4 and 5 are consecutive interior angles. Next proof. 2 givens. 1 and 2 make a linear pair. 1 and 4 are supplementary. Let's fill those in right away. 1 is given, and 3 is given. Okay. Hey, I just talked about this one. From line 1 to 2. If 1 and 2 make a linear pair, and they are supplementary, that is your supplementary theorem. Okay. Line 3 to 4. Okay, well, 4 says angle 2 is congruent to angle 4. Well, check this out. If 1 and 2 are supplementary and 1 and 4 are supplementary, then I can say that angle 2 is congruent to angle 4. If you recall, that was a bottom 2 on that note sheet. That is your congruent supplement theorem. Okay. Why is A parallel to B? We'll go back and look at your diagram. What types of angles are 2 and 4? 2 and 4, same side. One's inside, one's outside, similar location. These are corresponding angles. A is parallel to B because 2 and 4 are corresponding angles. Next page. Time for some algebra. All right, directions. Find X so that A is parallel to B. State which converse to use. So it's one of those 4 that we're going to put in right here. All right, these guys are inside opposite sides. These are alternate interiors. And we know they're congruent. Set them equal to each other. 10x minus 23 is 137. Add 23 over. 10x is 160. 10 goes in there 16 times. Number 2. One's outside, one's inside. Similar location. Those are corresponding. And these are congruent. Set them equal. 9x plus 11 is 74. Subtract that 11 over. 9 goes into 63. 7 times. Number 3, inside, same side, consecutive interiors. And these guys, remember, add up to 180. So add them up, equal it to 180. We got a 6x, a 96, and a negative 30. That gives me 66 equals 180. Subtract the 66 over. Divide that guy by 6. 6 goes in there 19 times. Number 4, both are outside and opposite sides. Those are alternate exteriors. And these are congruent. Set them equal. 7x plus 5 is 33. Subtract the 5 over. Divide by 7. That goes in there 4 times. Number 5. One's outside, one's inside, similar locations. Those are corresponding. Set them equal. Subtract the 5x over first. Add your 17 over. And then 3 goes in there 12 times. Number 6, inside, same side. Those are consecutive interiors. Add them up, equal it to 180. 12x, 4x, 16x. Negative 28 is 180. Add the 28 over. 16x is 208. 16 goes in there 13 times. Number 7. Inside, opposite sides, alternate interiors. Those are congruent, set them equal. I'm going to subtract the 6x over first. 5 is 2x minus 37. Add the 37 over, gives me 42. And 2 goes in there 21 times. Number 8. Outside, inside, similar location. Those are corresponding. Set them equal. Add the 18 over. 4 goes in there 27 times. Number 9, outside, opposite sides, alternate exteriors. Set them equal. I'll subtract the 23x to the right. So 1 is 4x minus 19. Add the 19 over. And then 4 goes in at 20 5 times. Number 10, inside, same side. Those add up to 180. Those are consecutive interiors. Combined like terms equal it to 180. You have 17 x's, negative 7 for the constants equals 180. Add the 7 over, divide by 17. That goes in there 11 times. And that's it for proving lines parallel.